This is the sequence 1.6 homework solution for the Ready, Set, Go. The first part of the Ready, it says find the missing term for each arithmetic sequence and state the common difference. Remember, this is an arithmetic sequence. That's why they can ask us for the common difference. This is your sequence 5, comma 11, comma blank, comma 23, comma 29, comma so on. They're asking us to find the common difference, right? So what you can do is you could grab the next term, subtract that from the previous term, and that should get you the difference. So let's see. 11 subtract 5, that's going to be equal to 6. Okay? Right? Let's see if decimals is correct. Let's clear that again. Let's do that. 29 subtract 3. 29 subtract 23. Let's see. That's also 6. Alright, good. So we know that right here, that the common difference is 6. So it is plus 6, right? It's increasing by 6 each time. So your sequence should be 5, 11, right? Plus 6. So 11 plus 6 should be 17. Plus 6, 23. 29 plus 6, 35, and so on, okay? Good. Next one. Again, we're going to find that common difference. So here, I'm going to grab the second term, subtract it by the previous term. So 3 subtract 7. I got negative 4. Let's try that again. I got negative 1 subtract. Should this be a negative? This should be negative. Hold on. Let's see if I can make a negative. I'm not sure how the negative appears here. So negative. How do I do negative 1 on here? Not quite sure. Let's see if I can do negative 1. Okay, negative 1 subtract 3. Alright, perfect. I guess I had to put that in a parentheses. Okay, that still is equal to negative 4, right? So good. So here, the common difference here is negative 4. So you're going to apply that. So the sequence should be 7 subtract 4 should be 3. Good. So it is 7, comma 3, comma subtract 4 to get the next term. Negative 1, negative 5, negative 9, and negative 13. Alright, there you go. Next, let's find this. So the only two terms are next to each other is the 60 and the 47. So I'm gonna try that. 60 subtract 47, 13. So my common difference here is 13. So my sequence should be 8 plus 13, right, which is the common difference, plus 13, 34, 47, right, and 60. Perfect. Matches up identically. Next, ooh, that looks a little, same process, right? You're subtracting. So it is, let's put this in parentheses, 8 divided by 3. Okay. Close the parentheses. Subtract that from the previous term. Ooh, 0.66666666. I think that should be roughly 1. Nope, is that 2/3? Yeah, that is 2/3. Okay. So the common difference here is 2/3. Okay. So your sequence should be 0, right? 2/3, right? Then you do 2/3 plus 2/3, 2/3 plus 2/3, right? Okay, all right. For those who want to see it, next I went what I think 2/3 oh, plus 2/3, right? That is roughly, that should be what 4 divided by 3 is. Oop. Perfect, you see? Good. So that, the next one should have been 4/3. After 4/3, it becomes okay. Alright, you're adding another one, so the next one should be 2. Then after that, the next one is going to be 8/3. Okay. Good. The next one, this is a little bit weird because you cannot subtract this by the previous term. Okay. And I don't want to throw in some algebra because we can use some algebra here to actually get it, but I would like you to think about it abstractly before trying to do the algebra, okay? So the way I approach this is that I'm going to just try different sequences, okay? From 5 to 25, okay? Let's try 2. Let's try 2, okay? So it should have been 5, 7, 9, right? 7, 9, 10, 11, 11, then 25. Nope, wouldn't work. Okay, let's try 5 as the common difference. Okay, right? Because 5 and 25, maybe 5 works. Okay, 5. The next one is 5 plus 5, which is 10. Plus 5 is 15. Plus 5 is 20, then finally 25. Right, perfect. So 5 is the common difference. Okay. Next one, 3 to negative 13. We know it's going down. Okay. So let's try negative 4. Okay. All right. So we start with 3. The next one is 3 subtract 4, which is negative 1. Right? Then next one, negative 1 subtract 4, which is negative 5. Okay. Negative 5 subtract 4 is negative 5 subtract 4, which is what? Negative 9. Then negative 9 subtract 4. Negative 9 subtract 4. Oh, that is our perfect negative 13. Perfect. So, negative 4 is the common difference. Okay. I was just eyeballing it. Okay. There you go. Right. Doing this, you would have to think about it abstractly. There is a way to do this using algebra. Okay. And I could explain that further down the class. Okay. But here you would just have to just try different common differences. Okay. But remember here, it's a subtraction because the values in the sequence are decreasing. Alright, so next we have two connex terms in an arithmetic sequence are given. Find the recursive function. So here's the recursive function. They're asking to find the recursive function of the arithmetic sequence. What I have here is the recursive function for the arithmetic sequence. Please understand that the D stands for the common ratio. So you have to find the common ratio. Okay. First of all, to find the common ratio, again, you would do, this is the 4th term, and this is the 3rd term. So to find the common ratio, common difference, right, you do 8 subtract 5, which is going to be equal to 3. Good? Alright? So, okay, you're going up by 3 each time. Good? So, here's the formula. Common difference, right? So common difference is equal to 3. This is your previous term. So I can even do this. So, right? So this would be the recursive function, right? Okay. So now let's find a of 5. So a of 5, plug in 5 for n. 5 goes in here, right? Simplify this. 5 minus 1, it's 4. Do we have function of 4? Yes, we do. Function of 4 is 8. This is 8. Okay. 3 plus 8, which is going to be 11. Good? Okay. That should make sense. Good. Alright. We can do this for a of 6, but again, I'm not going to be showing all the work for it. A of 6, right? Plug in 6 for n, right? N 6. 6 minus 1, which is 5. Good. So 3 plus function of 5. Function of 5 is 11. So that becomes 11. 3 plus 11, which is going to be equal to 14. Good. There you go. That is your function of 5 and your function of 6. Next one. Okay. We want to find the common difference again. So the common difference is going to be your 12 minus 20, right? Your next term, subtract your previous term, which is going to be equal to, looks like it's a negative 8. Okay. Right. So here, I'm going to write my common difference is going to be negative 8. All right. Bring down the recursive formula. Okay. The recursive formula is given exactly like this. So, plug in, what do I plug in for D here, which is a common difference? I'm going to plug in negative 8. Right? There you go. That would be the recursive formula function for number 8. Okay? They're asking us for function of 4, so let's do that. Right? Okay. So, they're asking us for n when n is equal to 4. So, this should be 4. Alright? Function of n 4 minus 1, which is going to be 3. Good. So, function of 4 is negative 8 plus function of 3. What is function of 3? We have function of 3 is equal to 12. So, put in 12 here. What is 8? Negative 8 plus 12. 8, 9, 10, 11, 12, which is going to be a positive 4. Good. All right. Next, we're going to grab this. We're going to do it for 5. Plug in 5 here for n. So n here is also 5. What is 5 minus 1, which is 4? Okay, they're saying here, negative 8 plus function of 4. We know function of 4 is 4 here, so substitute 4 in here. What is negative 8 plus 4? That should have been a negative 4. Sweet. So there you go. That's your function of 4, and that's your function of 5. Do I have room? No, let's go over here. Next, let's find the common difference first. Common difference here is going to be 8.7. Subtract, right, the 6th term minus the 5th term, which is 3.7. It looks like it's 5. Let's just double check here. All right. 8.7 subtract 3.7. Again, decimals are ugly. Just use a calculator. 5. Perfect. So common difference is 5. Alright, there you go. So, grab the recursive function. Alright. This is the recursive function. Alright. Now, I am trying to look for function of 7. So, plug in 7 here for n. 7 goes into here. What is 7 minus 1, which is going to be 6? What is my function of 6? I know function of 6 is 8.7. Oops, 8.7. Ooh, I forgot to plug in the d, which was 5, so this should be 5. Okay? So, what is 8.7 plus 5. Again, make your life easy. Get a calculator. 8.7 plus 5. 13.7. So this is 13.7. Okay. Next. Okay. I'm trying to find function of 8, so plug in 8 here for n, plug in 8 here for n. What is 8 minus 1, which is 7, right? That's the previous term. What is function of 7? Function of 7 here was 13.7. So again, let's check that in the calculator. What is 5 plus 13.7? 18.7. Good. So here it becomes 18.7. There you go. That is function of 7, and that is the function of 8 for this sequence. Good. That is 9. Oh, next. Here it says two consecutive terms in a geometric sequence are given. Find the recursive function. Here I wrote the recursive function for a geometric series, making sure that you understand that this is a geometric sequence. All right. So let's do it. We here for geometric sequence we have to find the common ratio, right? To find the ratio, we do your previous term divided by the like second term divided by the previous term, right? Previous term. Good. What does this mean? I'm going to show it to you. Right? The fourth term, subtract the third term, right? Okay. So the common ratio, right? Let's do that. So what is 10 divided by, let's just do this in a fraction so you can see this much better. 10 divided by 5, that should get me 2, right? You want to see that? Okay. 10 divided by 5. Perfect. 2. There you go. So, my common ratio here, R is equal to 2. Okay. Good. Alright, so, again, plug it into the geometric sequence. R here is for 2. Good. Alright. So that is my that's the geometric sequence recursive function. There you go. Then what you're going to do is you're going to plug in 3 here. So let's do that. Right? Because I'm trying to find 5, right? So plug in 5. Okay. Right? So this is also 5, right? 5 minus 1, which is just 4. What is 2 times function of 4? What is function of 4? We have that as 10. 2 times 10, which is going to be equal to 20. There you go. Okay. Next one. Right? I'm trying to find function of 6, right? Function 6, substitute 6 here for n, substitute 6 here for n. What is 6 minus 1, which is equal to 5? What is function of 5? We know that function of 5 is equal to 20, so you plug in 20. What is 2 times 20? That is going to be equal to 40. There you go. That is function of 5, and that is the function of 6. Good. Next one. Ooh. They're trying to play hardball here. Common ratio. Ha ha ha. Again, right? It is going to be the previous term, so third. So the third function of 10 divided by 20. Okay, that should be equal to, I believe it's 1/2. Right. Okay, that should be equal to 1/2. 1/2. Perfect. Okay, you want to see that? What's 10 divided by 20? That is equal to, perfect, 1/2, right? 0.5. All right, so nothing changed, right? Nothing changed. Okay. Right? We know that the R is equal to 1/2. Okay? So R becomes 1/2. There you go. That's the geometric sequence for the recursive function. Okay? Now I'm going to try to find the fourth. So plug in 4 here for n, 4 here for the n. What is function of 4 minus 1? Which 4 minus 1 is just 3. What is the function of 3? Function of 3 here is 10. Okay. What is 1/2 times 10? 5. There you go. Okay. Good. Alright, we're trying to find function of 5 now. Plug in 5 here for n, 5 here for n, 5 minus 1, which is 4. What is the function of 4? We know that that is 5. What is 1/2 times 5? That becomes 5 over 1/2. Okay? Pretty ugly, right? But the concept's not new. Okay? It's the same concept over and over, but it's just fractions, okay? Next, again, this is ugly. Common ratio. Alright, let's look at this. 2.94 divided by 20.58. Ooh, that looks interesting. Alright, let's clear this. Let's do this. 2.98 divided by 20.58. Oh, that is an ugly ratio. 2.98 divided by 20.58. Oh, why would they do that? That is very ugly. Okay, 12 is very ugly. I'm just gonna do it, but it's very ugly. Because if you simplify this in a fraction, why would they do that? Okay. Here you go. This is how it looks like in a fraction form. 149 over, yeah, 149 over 1029. That's how it looks like. That is the common ratio for this. 2.9, oh, sorry. 2.94 divided by 20.58. Oh, haha, it's actually pretty. It's actually 1 over 7. Okay, I typed it wrong in the calculator. 1 over 7, right? 2.94 divided by 20.58. Yep. Here, let me just show you it. Okay, what is it? 2.94 divided by 20.58. Okay, that should also be what 1 divided by 7 is, right? Perfect. Do you see? That equals to that decimal. 1.7 is also that decimal. Right? Perfect. Common ratio is 1.7. 1 over 7. Okay? Again. There you go. This is the geometric sequence for the recursive function. What are you plugging in here for r? It's 1 over 7. So put in 1 over 7 here. There you go. Alright. We want to find the, let's find the 7th term. So plug in 7 here. So what's 7 minus 1? Which is 6. What is the function of 6? Which is 2.94. Oh, that is so ugly. 1 over 7 times 2.94. Alright. Again, you're going to need a calculator when it gets this ugly. So, 94. Alright, this is roughly equal to 0.42. Okay? If you want to see that, here, let me show you. On decimals here, right? So, 1 divided by 7 times 2.94, right? You see how it equals to 0.42? So this is going to be equal to 0.42. Okay? Good? Alright, let's find, let's see if I have room to find the other one. Okay. I'm trying to find function of 8 now. Okay? 8. So plug in, substitute 8 for n. What's 8 subtract 1, which is 7. What is function of 7? We know function of 7 here from our previous one is 0.42. What you're going to do is 0.42 times 1 over 7. Okay, so let's just grab that. All right. So 1 divided by 7 times 0.42. Ooh, pretty. 0.06. So that is what? 0.06. So that is 0.06. So 0.06. There you go. That is the function of 8. Okay, there you go. Right? Make sure you make the substitution, then simplify the expression. Next, here's the goal. It asks you to find the indicated value of f of n. Find f of 5 and function of 0. Okay, so let's just plug this in. So you're looking for here. You're looking for 2 of n, right? So let's find the first one, right? This is going to substitute 5 here for n. So plug in 5 there. 2 to the 5th power is 32. Okay, you can say that that is going to be equal to 32. Good. And what is function of 0? Okay, so here, right, I wrote the equation. Substitute 0 for n. 2 to the 0 power. Remember, 2 to the anything to the 0 power, anything to the 0 power is always 1. Okay, so this is equal to 1. Alright, next. I have the function is 5 to the n, right? So I'm asking to find function of 4. So this is 4. Substitute 4 here for n. Okay? Right, where n is, you're substituting in for 4. What is 5 to the 4th power? Okay. 5 to the 4th power should be simple. 5 to the 4th power, sorry about that. 5 to the 4th power is 625. Okay. Next, we're going to do function of 1. Okay, substitute 1 in for n. What is 5 to the 1st power? 5 to the 1st power is 5, right? 5 times 1 is 5. Good. Next. Okay. They're asking us to do -2 to the nth power, right? So we're looking here at 3 for n. What this means, if you would like to see what this means, right, hold on, let me grab the equation for you. This means -2 is going to be times -2 times -2. That's what this means, okay? Right? This should be equal to -8, right? -2 times -2 is +4 times -2 is -8. Okay? Next, function of 0. Again, we can do that. Oops, sorry. I forgot to put your 3 here. Right. Next one, let's do 0 here. So 0 here. Anything to the 0th power is, again, anything to the 0 power is always 1. Anything to the 0 power is always 1. Next, 16. Okay. Alright. So, we have insert equation function of n is equal to -2 n. Okay? Now, okay, we're going to substitute in 3 for n. So, substitute 3 here for n. 3 here goes for n, 3 goes in here. What does this mean, right? There's a difference, okay? This means negative parentheses, insert equation, negative parentheses, right? 2 times 2 right, times 2. Close the parentheses. Okay, that's what this means, which is completely different from this. Okay, do you see how the parentheses was with the negative, but here, right, the negative here is not with the 2. Okay, so what does that mean? Okay, 2 times 2 is 4, right? 4 times 2 here is 8. Okay, so this becomes here is negative 8. Good. Next, what way are problems 15 and 16 different? This is how they're different. Okay. You're multiplying by negative 2 each time. Here, you're multiplying 2 each time. The negative's separate. Alright, that is how it's different. Okay. Let's do 8. Let's do 18. Okay. Let's do 18. Okay. Alright, so what we can do is, let's just write down the function first. Is equal to 3 plus 4n minus 1. Okay. Here you go. Right? They're asking us to find 5, so you plug in 5 here for n and 5 here for n. Right? Okay. What is 5 minus 1? 5 minus 1 is, okay, I can just show all the steps for you here. So here I sub in n is equal to 5, okay? Then here I simplify, right? So this becomes 4. 4 times 4, which is going to be equal to 16, right? 16 plus 3 is 19. There you go. Function of 5 is equal to 19. Alright? So, do you see how this is not an f here? It's a 4 here. Okay? Next one, find function of 0. So, we're going to, here's your original. Right? You're going to sub in here 0 for n, 0 for n, right? Let me write here, sub in n is equal to 0 because that's what it's asking for right there. Right? Let's do some algebra. Zero minus 1, which is going to be just negative 1. Okay. What is 4 times negative 1? That's going to be equal to negative 4. Negative 4 plus 3, that is going to be a negative 1. There you go. Okay, good. Next one, let's do this one as well. Okay. Equation. Alright, function of n is equal to 2 parentheses n minus 1 close parentheses plus 6. Alright, so let's find n of 1. Alright. Substitute here 1 for n. There you go. Next line, 1 minus 1, which is going to be equal to 0. Okay, let me just write this for you. Sub in n is equal to 1. Right, 2 times 0, which is going to be equal to 0, I believe. Correct. So, function of 1 is equal to 6. Next, I am asked to find function of 6. So, plug in 6 here for n, 6 here for n. Okay. What I did here was I sub in n is equal to 6. So, what is 6 minus 1, which is equal to 5? 2 times 5 is 10. Plus 6 is 16. So there you go. Function of 1 here is 6. Function of 6 here is 16. There you go. Those are all your answers for the sequence of 1.6.